To welcome all of you to today's webinar. We're covering going beyond the formula in Visual Basic for Applications, or VBA as most of you call it. This webinar is co-hosted by Experts Exchange and Brad Yundt, who is one of our top experts on Experts Exchange. I'm Jen Prentice. I work at Experts Exchange, and I'd personally like to thank all of you for attending this webinar. A few housekeeping items to note before we get started. First of all, if you take a look at the right side of your screen, you should see a chat window. This is where you can ask questions that you might have for Brad about his presentation, or questions that you might have for me about the webinar software in general. Just type your question into the message box and it gets sent directly to Brad and myself. If we have time at the end of the webinar, Brad will answer some of your questions. If not, Brad and I will personally follow up with all of you after the webinar to make sure that you get an answer to your question. Second, I want to let you guys know that you can see links in that chat window to download the .xls and .xlsm versions of the workbook that Brad will be using in his presentation today. You should have received those files via email earlier in the week, and if you're having trouble downloading those files, let me know. It's not essential that you have the files downloaded in order to follow along with Brad, but obviously people learn best by doing, so if you want to have those open and you want to take a look and follow along with him, that would be great. Last, if any of you have to leave the webinar early today, don't worry. We are recording Brad's presentation, and we will make it available to everyone early next week. So like I said a minute ago, this webinar is co-sponsored by Experts Exchange. Many of you in attendance today are already familiar with Experts Exchange. For those of you who are not, we're a technology help website where individuals and businesses go to find answers to their technology questions. We have nearly 3 million solutions in our knowledge base, covering a wide range of topics like Excel and Visual Basic, things like SQL Server, other Microsoft or even Apple products. So there's a good chance your question has already been asked by someone else. But if you don't see the answer you need, you can ask a question of your own and collaborate with thousands of experts like Brad, who, like I said, is one of our top experts on Experts Exchange, and get an answer to your question pretty quickly. So, excuse me, as I said before, we are thrilled to have Brad Yundt giving this webinar today. He is one of our top experts at Experts Exchange, and Brad is also a Microsoft MVP for Excel. He's been working with Excel since 1988, and in 1995, he discovered Excel's brand new Visual Basic feature, and he took advantage of it with a 50-page program that actually counted snowflakes, and he still uses that program today. He uses Excel and Visual Basic for applications for all of his routine engineering calculations. And in 2003, Brad said that his skills in Excel and Visual Basic for applications took a quantum leap, as he describes it, whenever he started participating on Experts Exchange, where he has since answered over 9,000 questions for people from all walks of life. He is currently a zone advisor on Experts Exchange, which means he helps make sure that you all get the right answer to your question. And 4 years ago, he was honored by Microsoft with their Most Valuable Professional Award for Excel, and has been honored with that every year since then. When he's not answering questions on Experts Exchange, Brad is a mechanical engineer, like I said, at Applied Research Associates. That is a researching and engineering company that they provide a broad range of technical expertise in defense technologies, civil engineering, and a number of other fields. If any of you listening are interested in learning more about Applied Research Associates, you can visit their website or contact Brad. His contact information is up there, and I will be putting it up again, as well as my contact information at the end of the webinar. So now I think that it's time for me to pass the presenter ball to Brad, the moment you've all been waiting for. Without further ado, let's get started while Brad goes behind the formula in Visual Basic for applications.
Okay, so you can see my workbook now.
I think your workbook should be up in just a minute. There we go. Your workbook is now up.
Okay, very good. What I want to do is start off by showing you how you might launch some macros, and the most ordinary way of doing it is to use a button. So Excel gives you actually two different kinds of buttons that you can use. One kind of button is from the Control toolbox, and the other kind of button is from the Forms toolbar. This top one here is from the Control toolbox, and you can see that it triggers a macro which displays a message box. The one from the Forms toolbar also can display a message box, and you'll notice that the macro has also changed the color of the text. Here's another one, and the text gets changed to a different color. Now, the location of the macros is different for the Control toolbox and for the Forms toolbar. For the Control toolbox, the macro is actually stored on the worksheet itself in the code pane. So if I right-click the Sheet tab and choose View Code, you can see that this is the macro right here that was called by the Control toolbox or ActiveX control button. Now if I Alt F11 to return back to the worksheet, if I right-click the Forms control button, I can choose Assign Macro, and then you'll see that it's looking for a macro called Forms Toolbar Command. And this other one is looking for the exact same macro, Forms Toolbar Command. Now, where is that located? Well, if you Alt F11 to go into the VBA editor, and you go into the A macros module sheet by double-clicking it, you'll see that I've got a macro called Forms Toolbar Command button. And both of those buttons call the same macro, and then there's logic inside that macro that determines which button did the calling. And what I do is I look at the top left cell of the shape object represented by the command button, and I look at the address of that, and if it happened to be cell A7, then I do one thing, and if it was cell A10, I do something else. And what's happening is I'm toggling between, in this case, I'm toggling between red and black text, and in this case I'm toggling between black and blue text. Now if I decode this statement, what I'm doing is I've got a shape object which is related to that Forms Toolbar Command button, and it has a text frame property, and the text frame property has a characters property, which has a font property, which has a color property, and now I want to set the color property of the text on that command button. And I'm using an IIF statement to do that, and the IIF statement says if font color, which is the color of the button font right now, if it happens to be red, change it to black. Otherwise, if it wasn't red, then change it to red. So that's the toggling capability right there. Now if I Alt F11 to go back to the worksheet, you can also use a picture object as a button. So in this case, I've got one of Dwight Eisenhower's quotations. And there's actually quite a few of them there that I can choose from as I keep clicking the button. And you can use auto shape objects. You know, this macro here, what it does is it zooms all the worksheets in the workbook to whatever size I've chosen for this worksheet. and it moves the active cell to cell A1. So if I push it again, you'll see that the active cell jumped back to A1, and it did so on each of the worksheets in this workbook. Now, as an engineer, I tend to use more user-defined functions than I do macros. And the reason for that is because I usually want an answer rather than to reformat a worksheet or manipulate a list or do some filing or some sorting or something like that. So for me, the essence is getting the calculation performed. So here, in this cell, I have a user-defined function called C or F to F. And what it does is it changes the temperature in this cell into Fahrenheit. And I've got a drop down over here that says whether this temperature is in degrees C or in degrees F. And if I change it to F, you'll notice that the function says, okay, this temperature is already in F, just give me the F value of 168. And if I change it to C, it converts the 168 Celsius to 334 Fahrenheit. Now let's see what's going on there with that. So if I Alt F11 to go to the VBA editor, and I go into UDF samples, by double-clicking it over here, you can see the function CRF to F. And it has two parameters being passed to it. There is a temperature parameter, which is a double precision variable, and then there is a Boolean variable called B Fahrenheit, which would be either true or false. And the stuff in green here are comments, and those are non-executable statements. I put them in there just to explain what's going on here. The actual logic is done right down here, and what I do is I test whether B Fahrenheit is true, and if it is, then I return the temperature parameter as the answer. Otherwise, I do a conversion of multiplying by 1.8 and adding 32. So that's how you return a value from a user-defined function. Now if I Alt plus a F11 to go back, I'll show you a couple of more sophisticated examples. Here, I've got a user-defined function called maxIf. And what I'm doing is I'm searching through a list, in this case the values in these cells here, and if the cell text contains the word valve, then I return the value from this column over here. And furthermore, I want the greatest such value. So what it's doing is it's looking for all the valves in this column here and then picking off the highest unit cost. So you can see that the biggest number is a metering pump. That's not a valve. Then you've got a gas mass flow meter. That's not a valve. But here you have a globe valve, and it's 1472. That's the third highest value, so that's what the function is returning. Now if I Alt F11, I can go back to the worksheet, to the code, and I can scroll down to maxIf, and I'm passing it a range variable, which is the cells being tested. I pass it a criteria, and in this case the criteria is that it contain the word valve, and I'm passing a range to return the maximum value from, which is this RG max. And the return value is going to be a double or double precision floating point number. So what I do is first I do some housekeeping. I test whether this range is the same size as this range here, and if not, then I've got a problem and I don't want to proceed any further. The next thing that I do is I initialize the value to a very large negative number, because what I'm going to be doing is I'm going to go through the entire list, and if I find a bigger number than the current value of maxIf, I replace it. So I start off with a very large negative number because anything that I find will be bigger, will be bigger than this. And what I'm doing is I'm going through each cell in the range RG test, and I'm incrementing a cell counter, the value I here, and I'm testing whether the criteria is numeric, and if it is, then I do this, and if it's not numeric, then I ask whether the value is, whether the criteria is true, and if the criteria is true, then I compare the value of the appropriate cell in range RG max to the current value of maxif, and if it's bigger, then I substitute them so that maxif becomes the value of RG max dot cell sub I. So what I'm doing is I'm going through row by row and I'm testing the criteria, and if the criteria is satisfied and if the value in RG max is bigger than the current value of maxif, then I say, okay, that's the new value of maxif. Okay, and if I Alt F11 to return, this function here, this one here, allowable stress. What I'm doing is I've got a lookup table here where I've got different materials, and then I've got different temperatures over here, and for each of the different temperatures and each of the different materials, I have an allowable stress, which is an engineering property that's commonly used. So the question that I'm asking is, for this particular type of material, which is a kind of carbon steel, and a temperature of 850 F, what is the allowable stress? So if I go over here to 850 F, the value should be 9.3. The function does return 9.3. And if I Alt F11, I'm explaining what's going on over here in the allowable stress function. And what I want to show you here is that you can actually use worksheet functions within the VBA code. And the way that you do that is you just say application dot and then the name of the worksheet function. So I set up a range variable here. I have a named range on the worksheet called TB allowable stress temps. I have another named range on the worksheet called TB allowable stress. And then I have one called TB allowable stress materials. So I have three range variables that point to cells on a worksheet. I've initialized them to named ranges on those worksheets. And what I'm doing is I'm returning the location of the match to the material in this named range RG materials. And then using that, I can set up a row of values to test, and I'm using the index function for that purpose. And what I want to do is I want to pick the ith row in that RG stress range of cells. And then I ask the question, is there an exact match for the temperature? Looking at the temperature data, and if there is an exact match, then the allowable stress is equal to this value here. But if there was not an exact match, then I want to do some interpolation. So the interpolation that I'm doing is just going back to the worksheet. If I had passed it, for example, 825, there's no value for 825. It's only 800 and 850. So what I would do is take these two values and then average them. And that would be the return value. And that's what I'm doing in this bit of code here. Now another thing that I wanted to show you is the select case construction. And what I'm doing here is I'm saying select case material, and then there's one or more choices called a case, and then you can do one or more statements after you've matched that case. So if the material happened to be 304L, or if it happened to be A516 grade 70, then the temperature limit would be 900F. If the material were 304 or 316, then the temperature limit would be a little bit higher, 1000F. So that's what I'm doing with this. And this is an alternative to having a series of if, then, else if, then, type statements. So I think that the select case is fairly nice to read as far as the code is concerned, so I like to use it a lot. And then at the very end, I'm doing a application.evaluate, and here what I'm doing is I'm constructing a worksheet formula, and then I'm going to evaluate that worksheet formula, and from that return an answer as allowable stress. So you do that with application.evaluate, and then this here, this is a string variable that is going to resolve to something that looks just like a worksheet formula or a worksheet expression. Now if I return back to the worksheet, the last thing that I want to show you is that a function can return more than one value at the same time, if you would like it to. So here I've got a function called pipe delta P gradient, and you can notice that it's in an array formula with the curly braces there. And what's happening is I'm returning two values to these two cells with one function call. And the reason that I might want to do that is because it's actually more efficient to return multiple values with one function call rather than doing the calculation once for this and then redo the exact same calculation over here for this answer in this cell. So the way that you do that is you go back into the VBA editor, and I'm doing my engineering calculations here, and then the last statement right here is I'm saying that pipe delta P gradient equals array dP gradient and RE. So it's returning two values, the dP gradient value and the Reynolds number or RE value. And that's how I was able to set up an array formula and return both of those values with one function call. Now, why might you want to do that? On the snowflake counting problem that was mentioned at the very beginning, I returned an array of 13 columns by, I believe, 30 some odd rows. And by returning all those values at once, I was able to cut the execution time from approximately 5 minutes down to about 20 seconds. And this was back in 1995. So that was an amazing improvement in computation speed just by using an array formula and returning all the values at once. The exact same program still running today will do the calculations almost as fast as you can type in the data. But that's a reflection of increased computer speeds. Now, next thing that I want to show you is recording macros. And that's how a lot of people learn how to write macros and learn how to program. And what you can do is you can initiate, by clicking this button here, the recording of a macro to do any kind of a worksheet formatting or user interface modifying set of statements. So for example, I'll turn the macro recorder on, and I'll click OK, and let's go into page layout, and let's do a footer, and let's let's say, today's date in the right footer. So the code for that is ampersand square bracket date square bracket. I'll close that, say OK here, and then I will click the square and I'll turn the macro recorder off. Now if I Alt F11 to go back into the VBA editor, it will add a module for the newly recorded macro. In this case it happens to be module 2. And if I double click that, you can see that here is the macro that got recorded. Now I only did one thing. All I did was to change the footer. But you'll notice that a lot of stuff got recorded. And that's because the macro recorder does not necessarily record the most efficient way of doing something, but it records it in a consistent fashion. So if we go looking through this code, we'll see that looking down here, here it is. Right footer equals ampersand D. So that's the code that it recorded. All the rest of this stuff really isn't required. And if you look at module 1, I've reduced all of that code down to this one statement here, active page.pagesetup.rightFooter equals ampersand D. So this little short macro does the same thing as this long macro over here. And what I would encourage people to do if they record macros is to figure out what is the important part, what's the meat, and then just comment out by putting in a single quote in front of the statements. Just comment out all the stuff that you think is unimportant, and then try running your macro and see if it still works. And if it still works, you know you don't need those statements. You can delete them. And when you've done all of that, you'll find that you're left with something like this. And then what I did is I combined this by doing that, just deleting that text and getting rid of the width and the end width, and then deleting those statements and those statements and those statements, and I'm left with the exact same macro once again. Now if I Alt F11 return back to the worksheet, I've laid out some other examples for what you can do in situations like this. For example, if you wanted to indent and format a cell, what you might do is turn the macro recorder on and let us indent and let us change let's say to the Calibri font, and then we'll turn the macro recorder off. And if I Alt F11 and go to module 2, you can see that it still recorded some useless stuff, but it was a lot less egregious than the example of the page setup. And here, the useful parts, see the name of the font is Calibri, that's true, and then the indent level is done right here. So I probably don't need to have this stuff done, and I can get rid of the width, and I can get rid of that, and the end width, and what I'm left with is two statements that do the exact same thing. Now the next thing that you might want to be thinking about is where you're going to store your macros. And A good place to store them, if you're going to use them frequently, is in your personal .xlsm workbook. And if you don't already have one, when you record a macro, you have the choice of putting it in your personal macro workbook right there. So all you have to do is create the personal .xlsm, and then you can, it'll always be opened whenever you launch Excel. So you'll always have it ready to use in the future. All right, now next thing that I want to show you is how you might apply some macros in typical situations. Here what I'm doing is I'm setting up a bill of materials for an auto dealer. And what I've done to start things off is I've got a drop down here for the type of car that you're choosing. And then I want to create some checkboxes for some options. So if I double click these cells, I change them into checkboxes, and now I'm ready to use the tool. And let's choose a two-door hatchback, and let us pick a really deluxe sound system with a GPS navigator, and let's check all the options. So there's the price of my car right there before you start haggling with the dealer. And the way that the double clicking is working, if I go into View Code, it's actually in the worksheet itself, code pane, and there is an event called before double click. So whenever you double click a cell, if you happen to have one of these worksheet before double click event subs in there, it will run. And in this case, what I'm doing is I'm adding a checkbox. I'm setting the caption of the checkbox to whatever the cell had contained beforehand. I'm linking the result, which is a true-false value, of the checkbox to that same cell. And I am naming the checkbox CB and then whatever the address of the cell happened to have been. And I'm changing the font color on the cell to white. So that's what I'm doing with the checkbox. Now if you, let's see, so if I select those cells there, you can see that the unchecked checkbox actually has a value of false, and the checked checkboxes actually have a value of true. So that's how this tool is working. Now another common problem is time-stamping data. So what a person might want to do is just capture the date and time that you do something. So if I do a few things here, A, B, and C, you'll see that the time that I did them is captured right there, the date and the time. And if I didn't really mean to do that, the cell value is cleared. Now the way that I'm doing that is once again with an event sub, and if I go into the view code, you'll see an event called the worksheet change. And what I'm doing is I've got a range of cells that I am watching. In this case, it is cells A4 to A10 and C4 to C10. And I'm comparing that range of cells to the cell that actually got changed, cell or cells that actually got changed, which is called target. And the intersection of those two ranges is going to be called targ, which is another range variable. And if in fact there wasn't any intersection between the cells that got changed and A4 to A10 or C4 to C10, if there's no intersection between that and target, then targ will have the value of nothing. And if there was an intersection, then targ will have the value of the cells that got changed. So in this case, if targ is nothing, what I want to do is I want to exit the sub. I don't do anything. And if targ was something, then I want to turn events off because I'm going to be changing values. And then what I want to do is go through each cell in that intersection, targ.cells, and if the value of that cell was blank or an empty string equals double quote, then I want to clear the cell to the right of it. Otherwise, I want to put today's date in that cell. And I pre-formatted that adjacent cell to receive today's date and give you the date and the time. And then I turn events back on. Now the reason that I turned events off is that if I hadn't done that, the moment that I changed the value of a cell with this statement or with this statement, this sub would be called once again. And you would get this never-ending chain of sub being called if you keep changing the value of a cell. So to forestall that, I turn events off so that now when I change this value, Excel does not call the worksheet change sub, but instead just continues on executing the VBA code. But the price for that is you have to turn events back on. And if you don't do that, then your code won't work the next time that you want to use it. And that's actually a mistake that I make fairly frequently. Not that I forget to turn events back on, but I have a fatal error in my code, and whenever there's a fatal error and events are off, the events stay off. So in cases like that, what I will do is I will type in the immediate pane at the bottom here, application dot enable events equals true, and then when I hit the enter key, it executes that statement and events are now turned back on. Okay, another thing that people like to do is they like to find duplicates on a list. So here I've set up 4 different things that one might want to do. One of them being to find duplicates on a list, another being to find items that are on both lists, another one being items that are on one list but not the other list, and finally if you have a product and a description, maybe the description doesn't match. So let's try that one. So let's check the list I want to check. And here's the description cells. It just says any cell, so I'll pick that. And I want results to go here. And it's giving me a formula that's in the R1C1 notation. So obviously I did not debug that bit of code. Let's try a different example. Cells that I want to check for duplicates. Put the results over here. Okay, now that one works. So if I go into the duplicates tab over here, and you can see that the duplicate finder, that was the one that was not working, and it's building a formula like this, and it is a formula that is in R1C1 notation, and I set the formula R1C1 property equal to this, and that should have worked. And then here's the problem one. Description matcher. Searching a list in the description field for cases where description doesn't match. And here I build the formula, and I'm building it in R1C1 notation. And I just say results.formula equals formula. So if I change that to R1C1, now I should be able to go back and make it work. Check this list. Bingo, now it works. Okay, the next application that I want to show you, this is actually a question from Experts Exchange. And the backstory of the question is that the CFO of a medical college had 32 different departments, and he was doing budgeting, annual budgeting. And typically what he would do is develop a consolidated budget for the entire medical college, and then he would create worksheets that built up the overall totals and send one worksheet out to each of the 32 different department managers. They would do some budgeting activities and then return the finished worksheets back to him, and he would compile their worksheets into the overall consolidated workbook. And what he told me is that this process took him, it actually took the 3 people in his department a full afternoon to do. And with that much effort and that many people, of course, mistakes are made. So over the course of this particular question, we developed 3 pieces of code. One piece took his consolidated workbook and spun out departmental worksheets from that. So he had 32 different worksheets that were spun out as separate workbooks. They were then emailed out using the second sub to the department managers, and then when the department managers returned them back to him, he put them all in a special folder, and then he ran the third macro, and the third macro reassembled all the workbooks. And to drive this process, besides the 3 pieces of code, what you need is the name of the department manager, you need his email address, and you need the name of the workbook that he's supposed to be getting. So you build a list like this, and then you will pass this list to the second sub here, and it will go looking for these workbooks in a certain folder, and it will send them out by email to the department managers. Now if we Alt F11, we can see how that's actually working. Budget utilities. And the first bit of code was sheet exporter, and what it's doing is it is splitting the workbook up into different workbooks for each worksheet, and it tests whether the worksheet is visible or not. If the worksheet is not visible, for example, he may have hidden the overall summary worksheet, then you would not be sending it to anybody or creating a separate workbook from it. So what he does is, he has certain cells where he's grabbing inputs from the master worksheet. In his case, it happened to be B10 to M13, B26 to M31, and B43 to M45. So we're going to take those cells and we're going to replace them with the values returned by the formulas in the workbooks that are being sent to the department managers. By doing that, you send the department manager a workbook that does not contain any linked formulas to other workbooks. So that's being done in this block of code here. So this is actually a compound range. It has 3 non-contiguous portions to it. So each of those non-contiguous areas in that range we're going to consider separately. We're going to copy it, and then we're going to paste it in the workbook that we created with the department manager's worksheet. And then we're going to protect the new worksheet with a password, and then we're going to save it with a certain name according to the worksheet name, and then we're going to close it. Now the next step is sending the email. We do that with CDO mail workbooks, and the code for this was actually taken from another MVP, Ron De Bruyne, and there's a couple places where you have to configure the code in here. One of them is you need to put in the address to your mail server. For example, I'm just saying it's going to be mail.sumisp.com, but whatever it happens to be for your email server, your SMTP server, you would put that address right here. Another thing that you'll want to do is you'll want to change your sending email address, which is frequently along the lines of byundt@myisp.com. So in my case, it'd be byundt@ara.com if I was sending it from here. So that's how I would change that. Environment of username returns my Windows login name, and that's frequently equal to your username for sending emails. And the subject, you might want to change that. In this case, it was departmental budget. And then you can change the text body, which is, in this case, please update as required, then return as an attachment. So once you've made those updates, then you should be able to send the emails out. And then the final sub was sheet importer. And what it's doing is it asks the question, just pick a file, any file from the directory that holds the returned workbooks. And we then parse the file path and file name. We get the path from that. And then using that path, we use the dir command to find all the Excel workbooks that happen to be in that folder, and return them one at a time, open them, and then add them to the master workbook. And in this case, we're not adding the actual worksheet, we're actually adding the manager's inputs, which happen to be in cells B14 to M15 and B22 to M33. So we copy from those cells into the master workbook, and that imports his budget data. So when all is said and done, what I was told is that the sheet exporting step is one press of a button, and it takes about a minute to create all of those supporting workbooks. It takes another minute to email them out, and it takes a third minute to import them back. So we've changed something that took 3 people a whole afternoon to something that takes 1 person 3 minutes. Pretty good improvement. Now, another thing that I wanted to show you, this is an engineering example. One of the most underutilized features in Excel is styles. And what I've done here is I have a general problem of wanting to have calculations or results displayed in metric units in some cases, and in other cases using English units, depending on whether the customer is in this country or overseas. So what I've done is I've got a table of values here, and I have, in my case, 50 or 100 worksheets that will draw these values here and then apply them in different cells, perhaps using formulas. And then I want to display those values using the engineering units, pounds per hour or kilograms per hour or gallons per hour or whatever happens to be appropriate. So what I'm doing is if I change the units, for example, from pounds to kilograms, and maybe I want to use bars for pressure and temperatures for Celsius and volumetric flow, I want to use liters per hour, and you can see that the numbers here changed accordingly. And if I want to have different numbers of decimal places, for example, I might want to have 1 decimal place for bars. It updated those numbers so that now this style has both the number of decimal places and it has the engineering unit in there. Now, if you go into the style menu over here, you can see that I've created a mass flow style, a pressure style, a temperature style, and a volume flow style. So what I've done is whenever I enter a value, for example, 173, okay, now I can apply the pressure style to it, and automatically you inherit the number of decimal places and you inherit the engineering units. So I will tell you from personal experience, in the case of a bioreactor package that might have 100 data sheets, if I had to change it from using Fahrenheit and pounds per hour over to using metric units, that would probably take me at least a full day of very boring work to do. But by using the code and using the styles, I can do all of that in about a minute. So that's pretty good improvement for an engineer. Next thing that I want to show you is some charting stuff. And here I've got two different charts. And the first chart, it's actually for fertilizer. And this was again an experts exchange question. And the guy was complaining that the color bars weren't the same on these two charts. And if you look at it very carefully, you'll see that in the two lists being plotted, one of them has calcium and the other one does not. So this one here has a bar for calcium, and this chart here, there's no data for the calcium. So the calcium color was actually taken by the next element on the list, which would be magnesium. Now if I click this button here, what it will do is assign consistent colors to the different elements. So now you can compare the red column to the fact that there isn't a red column now over here. You can compare the magnesium magenta to magenta. You can compare grass green to grass green. You can compare cyan to cyan, and it's all consistent. Now how did I do that? If you go into the charting block over here, you'll see that I am referring to ActiveSheet.chart objects, and that's a collection of all the embedded charts that are on that worksheet. Now they're actually stored in a container called a chart object. So first I loop through all the chart objects, and then I get the chart associated with that chart object using OCHT.chart. And the next thing that I do is I look at series collection 1, and I go through all of the points in that series collection 1, and I look at the X value to see what element it is. And if it's N for nitrogen, then I use 45 as the bar color. And if it's P, then I use 4, which is a light green, and so on and so forth. So that's how I set it up for each of the charts. And in this case, I'm looping through charts 3 and chart 5 that are on this worksheet. Those are the only two charts that I care about. So I'm using a select case to pick off, to exclude chart 3 and chart 5, and then the other charts are the ones that I'm colorizing. So this chart here was chart 1. This chart here was chart 2, and this chart here was chart 5. So I'm not going to do chart 5, but I was going to do chart 1 and chart 2. Then go back, and then the next thing that I do is if the bar color is a number greater than 256, then I assume that it had an RGB color associated with it, such as bar color equals RGB 253, 187, 23. And that's if you use the color picker to pick the color for that bar. If it's less than 256, then I assume it's a color index that gets the value. So that's how I'm doing it. And this question here, also from Experts Exchange question, the complaint was that you had one set of data shown over here, which is the growth, and some of the values are negative. And you have another set of data, and all of those values are positive. And what the fellow was asking for is that if 0 on this side here, he wanted to have 0 on the other side line up with it. Now, of course, it does. Right now you have 0 on this side, you have 0 on that side, they both line up. But the problem is that the negative numbers don't show on this chart. So what he wanted to do was to change the axis, and he wanted the minimum and maximum to be auto. So there's his problem in a nutshell, because here's the 0, and it doesn't line up with that 0 there. So he said, how can you force the 0 here to line up with the 0 there? So I wrote a macro. So you run the macro, and now you have a 0 here, and you have a 0 there, and they both line up. That's what he was asking for. So the way that I'm doing that is I actually have to calculate what is the value of the 0 in terms of chart coordinates. And I do it twice. I do it once where the chart actually is, and then I go through and I repeat the calculation. And the reason that I do that is because if I didn't, and the chart, as actually happened over here, it did not go below 0, and over here it did go below 0, I would get the thing half solved and not fully solved. So by going through it twice for I equals 1 to 2, then I get the calculation to work out fully resolved. And I end up setting the minimum scale value for each of the, and the maximum scale value for each of the two axes. And by setting the min scale and the max scale through this calculation here, I make the zeros line up, and then the actual minimum and the actual maximum are wherever they want to be. So in this case, I'm running from minus 600,000 to plus 800,000, and in this case I'm running from minus 10% to plus 15%. But the zeros really do line up. Now the last thing that I wanted to show you is, if anyone was following along with me, you almost assuredly had macros enabled. And the way that I know that is because I have code in here that enforces the macro that was being enabled. If you didn't enable macros, you would have actually gotten a worksheet that displayed a message saying, here's how to enable the macros. So I've got a worksheet called WS Enable Macros, which is hidden right now. So I'm going to set its visible property equal to visible. Execute in the immediate pane. And now you would have seen this worksheet here, and only this worksheet, had you not enabled macros. And the way that I accomplished that was in this workbook code pane. I've got 5 subs that are working together in order to enforce macros. And when the workbook opens, the first thing that it does is, if macros are enabled, it runs the show sheets sub. And what show sheets does is it hides the worksheet that contains the enable macros instruction, and it displays the macros, it displays the worksheets for everything else except for ones called top secret and confidential. Now I don't happen to have these, but I could have. And if I would have had these worksheets, they would not be displayed. And the next bit is, when you are saving the workbook, you want to trap the save event, and you need to hide all the worksheets except for the one with macro instructions. And you need to do that before you save the worksheet. So that's done by the special save routine here. And then before the workbook is closed, you also want to see if the workbook has been saved or needs to be saved. And if it does, then you want to use the special save once again. So, this bit of code here you can copy and use verbatim if you like to. At this point here, I think I'm ready for any questions people might have.
All right. Actually, a number of you had sent me a message with with some questions, and so we're not going to have time to address all of them, but I will. We have about 1 minute, so I'll ask the last question that someone asked, and they said, what is a good reference for the actual function names or variables used in your VBA code for both VBA and Excel? This is by, I believe, Darnall, and he or she said that I learned a number of new functions today, and I'm sure that there are more that I could be using. So, Brad, do you have any suggestions?
Well, the online help is your friend. So it's an optional install with I believe Excel 2003. I think it's part of the normal install with Excel 2007 and 2010. But if you don't have it, then you definitely want to install VBA Help. And to do that, you'll have to visit the Add Remove Programs control panel and select that, and you'll need to present your Office CD-ROM. But if it happened to be installed, what you'll be able to do is to type in the help bar up here. Let's see, let's look for saved. See what happens. And I'll go out on the web in this case and go look for the latest version of the help on the office.com website. And if we're a little bit patient, it should do that for us.
Sounds good. If any of you, because it is noon, if any of you do need to leave, we will be sending out a recording of this webinar early next week. And if you don't have to leave, then stick around, and Brad's going to finish answering this question.
So in this case, it'll tell you that the workbook.save property is true if no changes have been made to the workbook since it was last saved. And once you do start making changes, it becomes false. So that's what the property is. That's how you'd use it. They give you a little example over here. And that's one way of discovering the properties or the methods of the various features of the object model. The other way of discovering them is to record a macro. Now, I never use a recorded macro in a production situation, but I often do record macros. And I record the macro to see exactly what is the name of the property or the method that Excel is using to do something. So that's a very common use of recording macros by people even that are very good at it. We still do record macros just to see what's what.
Sounds good. Well, thank you very much, Brad. I know that I speak for everyone here who said that, or when I say that, I learned so much today. And now that we're done with questions, I'm just going to put my contact information as well as Brad's contact information up here on the screen. And as I said, those of you who asked questions earlier in the webinar, we will be addressing those via email. So thank you all for attending. Have a great day, and I will be sending out the recording next week. All right, bye.